Alright, you guys, if you could please turn to this page of your notes. One of the most famous theorems in mathematics is the Pythagorean theorem, named for the ancient Greek mathematician Pythagoras around 500 BC. This theorem can be used to find information about the lengths of the side of a right triangle. In any right triangle, the longest side, or the side across from the right angle, is going to be called the hypotenuse. The other two sides are going to be called the legs. In a right triangle, the square of the length of the hypotenuse, where's my cursor? There it is equal to the sum of the squares of the lengths of the legs. Okay? The converse of the Pythagorean theorem is also true. You can use it to verify that a triangle with given side lengths is a right triangle. So over here, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So basically, if a squared plus b squared equals c squared, you know it's a right triangle. Okay? Some other things we can determine, these are actually not part of the converse of the Pythagorean theorem, but they're related, so I just kind of threw them in the box. If c squared is less than a squared plus b squared, you know the triangle is acute. If c squared is greater than a squared plus b squared, remember c is the longest side, then the triangle is obtuse. Okay? A Pythagorean triple is a set of three positive integers a, b, and c that satisfy this equation, c squared equals a squared plus b squared. The most common Pythagorean triples are the ones that I typed out for you and then I drew a box around them. The other triples below are the result of multiplying each integer by the same factor. So for example, 3, 4, and 5, if I multiply all those by 2, I get 6, 8, and 10. Or if I multiply them by 3, I get 9, 12, 15. If I multiply it by 10, 30, 40, 50, you can multiply these numbers by any number. So I put an X here. And you will get another triple. Okay? You may find it helpful to memorize the basic Pythagorean triples, the ones that I've boxed for you, because they have a tendency to appear on tests, especially the CST that you'll be taking at the end of the year. Alright, this theorem states that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So what that basically says is that if you have a right triangle and you draw an altitude to the hypotenuse, an altitude is a line that is perpendicular to the opposite side. So this CD would be the altitude. The two triangles it splits it into, so in this case, let's see here, where's my cursor? Yep. This triangle and this triangle are similar to each other, and they're both similar to the original triangle. So if you guys can see, when you draw the altitude, you actually have three triangles. You have the big triangle, ABC, the medium triangle, ACD, and the small triangle, CBD. Okay, and all three of these triangles are similar to each other. Alright, a 45-45-90 triangle is an isosceles right triangle that can be formed by cutting a square in half. Okay, so as hopefully you guys can see that this is kind of like half a square. In a 45-45-90 triangle, 45-45-90 meaning the angles are 45, 45, and 90 degrees, the hypotenuse is root 2 times as long as each leg. So for example, if I said that each of these legs were 4 inches, you would know that the hypotenuse would be 4 root 2 inches. Okay? A 30-60-90 triangle can be formed by dividing an equilateral triangle in half. Okay? In a 30-60-90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is root 3 times as long as the shorter leg. One thing to notice, I had to distinguish between the shorter leg and the longer leg. In a 45-45-90 triangle, the legs are the same, but in a 30-60-90 triangle, you have a short leg, I called it short, and a long leg, okay? But still one hypotenuse. So for example, let's say the short leg was 3 centimeters long. The long leg would be 3√3 centimeters, and the hypotenuse would be 6, because 3 times 2 is 6. There are 3 trigonometric ratios that you will need to know for this class: sine, cosine, and tangent. A trigonometric ratio, or I usually call them trig ratios, is a ratio of the lengths of 2 sides in a right triangle. You can use trig ratios to find the measure of a side or the measure of an acute angle in a right triangle. The acronym that I wrote over here is pronounced SOHCAHTOA, and this acronym can be used to memorize the 3 trig ratios. So for example, sine is opposite over hypotenuse, so SOH. So cosine is adjacent over hypotenuse, CAH, CA, and tangent is opposite over adjacent, so TOA, TOA. That's how you get SOHCAHTOA. Okay? The adjacent side and the opposite side, you guys already know what the hypotenuse is. Depending on which of the acute angles you're referring to, for example, if you're referring to angle A in this diagram, the opposite side is the side that does not touch the angle, the side that's exactly across from it. So in this case, CB. The adjacent side is the side that's touching the angle that is not the hypotenuse. So if you're talking about angle A, this would be the opposite side, this would be the adjacent side. If you're talking about angle B, this would be the opposite side and this would be the adjacent side. Okay, but the hypotenuse stays the same. If you look up at an object, the angle your line of sight makes with a horizontal line is called the angle of elevation, like so. If you look down at an object, the angle your line of sight makes with the horizontal line is called the angle of depression. Okay? Alright, these 2 lists over here, we're actually going to be doing both of these things in class. Go ahead and just write this down so you don't have to take time to do it in class. But I'm actually going to walk you through these steps with the calculators in class, okay? So just copy it down for now, and we'll go over it in class. To solve a right triangle means to find the measures of all its sides and angles. You can solve a right triangle if you know either of these 2 things, either 2 sides or 1 side and 1 angle. Okay? If you're given 2 sides, this is generally how you want to go about finding the 1 missing side and the 2 missing angles. You want to use if you have 2 sides, go ahead and use the Pythagorean theorem to find the 3rd side, and then you can use inverse trig ratios to find the missing angles. And we will do some of this in class together. If you have 1 side and 1 angle, well, you know it's a right triangle, so one of the angles is 90 degrees. If you have a second angle, you can use the triangle sum theorem, that's the theorem that says all the angles in a triangle add up to 180, to find the 3rd angle. And then you can use regular trig ratios to find the missing sides. And that's all for Unit 7.